This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 2, Lesson 9, Block Load Assembly and the Load Estimate. There's no new formula here. A block load is an assembly. You take every component you've already built, envelope, fenestration, internal gains, infiltration, ventilation, add them into one peak, then split that peak into a sensible part and a latent part with the sensible heat ratio. We'll frame it with the one balance the handbook prints, lay out the recipe, then assemble a small office block end to end. Concept 1. What a block load actually is. It's the total heat a zone's equipment must handle at the design peak, and you build it by adding the component gains from the earlier lessons. The handbook prints every piece but no whole zone total. Assembly is a method, not a formula. And mind the word block. The block is the whole zone summed together, which is usually less than adding each room's private peak, because the rooms don't all peak at the same instant. Concept 2. The one printed anchor. There's no block load equation, but the handbook does print the balance that justifies the whole method, the space sensible and moisture balance. In words, the supply air must carry away exactly the sensible heat the space gains plus the moisture it gains. That's the physics behind add the components, then size the air. It's the only pill the assembly itself leans on. Every component number brings its own. Concept 3. The block is a stack. Picture every component gain stacked into one bar. Read it two ways from the same picture. The whole stack is the total load, and the sensible share of that whole is the sensible heat ratio, which fixes the slope of the supply air line. A dry office is mostly sensible, so a high ratio. Add people or a kitchen, and the latent grows and the ratio drops. Keep sensible and latent in two separate running totals. That's what makes the ratio real at the end. Concept 4. The two ways the sum goes wrong. First, timing. The pieces don't all peak at the same hour. Solar peaks mid-afternoon, the crowd mid-morning. So the real block peak is the largest sum at 1 hour, not the sum of each part's own maximum. The handbook prints no cooling load factor or time lag method to shift gains in time, so treat coincidence as a concept and just sum the design hour numbers you're given. Second, double counting. Window and door leakage is the same air as infiltration. Count it once. We put it in infiltration, so the fenestration entry is conduction and solar only. Setup. One small office at summer design. Inside 75.5 humidity, outside 95. So a 20-degree temperature difference and a humidity ratio difference of 0.0068. 6 people, 1,000 watts of lighting, some plug load 100 cubic feet a minute of outdoor air, 50 of infiltration. The tally pulls each piece from its own lesson, with 2 columns, sensible and latent. Notice the fenestration row is conduction and solar only. Its leakage air is folded into the infiltration row, so we count that air just once. Solve. Sum the columns. Add the sensible column, and it's 20,300. Add the latent column, people, infiltration, ventilation, and it's 5,880. Together, the total block is 26,180, about 2¼ tons. The sensible heat ratio is the sensible over the total, 0.78, a typical office mix. And the two airstreams share one temperature difference and one humidity ratio difference, because they're the same outdoor air entering the same room, so their latent parts land 2-to-1 with their flows. Solve. Part 2. From block to air. The space balance says the supply air must remove the block, so size the airflow off the sensible load, and the 20-degree room to supply drop, about 923 cubic feet a minute. The ratio then fixes how dry that air must be. The coil also has to pull the 5,880 of latent to hold the room at 50%. Sensible sets the airflow. Latent sets the moisture the coil removes. That's the payoff. The block isn't the end, it's the input that sizes the equipment. Traps. 5 ways this bites. 1. There's no block load formula. Assemble the pieces, the sum has no pill. 2. Keep sensible and latent in separate totals, or the ratio is meaningless and the coil is wrong. 3. Count window and door leakage once, it's the same air as infiltration. 4. The block isn't the sum of each room's peak, and the parts don't peak together. There's no cooling load factor in the handbook to shift gains in time. 5. Infiltration and ventilation are the same outdoor air, so use one temperature difference and one humidity ratio difference. Quick recall. A block load is a method, not a formula. The handbook prints no total, only the space balance that justifies summing. List the components: envelope, fenestration, internal, infiltration, ventilation. Keep sensible and latent in separate columns. Add each, and the total is their sum. The ratio is sensible over total, and its size is the air. Watch coincidence. The block is the largest sum at 1 hour, with no cooling load factor to lean on, and count leakage once. Golden rule: assemble, don't look up. Next up, Lesson 10, Exam Strategy and Workload Problems, the Week 2 Capstone. A rapid guide to which pill and which table each game needs. Then 3 or 4 exam-style problems spanning the whole week. An envelope and fenestration wall, an internal gains office, an infiltration and ventilation case, and a full block load assembly. Every answer re-derived from the handbook. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.